Over half of New Orleans is located below sea level. This paved city is basically a big bowl. When water comes in, the only way to get it out is with pumps. So when the pumps failed during Katrina, the lower Ninth Ward was left underwater for more than 3 weeks.
We're in a situation where our community has a real fear of water, and it's a valid fear of water.
Right.
So the folks in this neighborhood have a different mindset on water, and we're trying to change that paradigm.
To make sure this neighborhood is not left underwater again, engineers have found an innovative solution to radically reduce the need for pump stations, called pervious concrete.
As water runs off of our site, it does the opposite of what typical pavement does. Instead of a giant table that tilts water and flows it to the curb and gutter, this is a giant sponge that accepts rainwater, stores it in the concrete and below, and doesn't hit the curb and gutter and run off our streets.
So you're telling me this driveway and this sidewalk, when rain hits it, it's actually going to absorb that water?
Correct.
Unlike conventional concrete that repels water into the storm sewer, pervious concrete absorbs it. Filled with tiny air pockets, it allows water to flow through it and into the native marshland below, where hundreds and thousands of gallons can be stored naturally.
Do you have any actual finished stuff that we can see?
Yeah, we have a little mock-up right here.
All right, let's simulate right now. I'm a driveway, you're a rainstorm, and the rain's coming in.
It just stores up,
It's just eating it like a sponge.
and then it comes out the bottom.
And it's coming out the bottom, look at that. Now, typically, all that rain we just dumped down would go from this driveway into the sewer system and have to get pumped out.
Correct. At ultimate build-out, we will be saving several 100,000 gallons of water hitting the storm sewer every rain event.
And that all starts with you, me, and a bunch of guys pouring some concrete.
Absolutely.
Here comes. It doesn't look normal, right? It's much drier, thicker, and chunkier.
Because of this consistency, pervious concrete pours much slower than conventional concrete and dries much faster. So we have just 15 minutes before the concrete sets.
So we're actually trying to push the concrete out, but then actually compact it.
Yeah, we're gonna compact it. We're gonna pour it 3/4 of an inch higher.
Got it. What I'm doing right now is sort of the opposite of what you do with normal concrete. Typically, you vibrate concrete to get the air bubbles out. Here, we actually compact it tight to get lots of air bubbles inside of it. That's how the water goes through it.
Compacting the concrete is the most critical part of the process. If it's compacted too tight, it won't absorb the excess water. Too loose, and it'll crumble. To do the job quickly, they use a specialized 150-pound roller called a screed.
Ready?
You wanna pull it?
Yeah, now I'm pulling it. All right, come to me. Here we go. Stay with me. Here we go. Nice and slow. I'm making pervious concrete. You know why? Because I don't want concrete to push water in the sewer system, do you? No, you don't.
Good job, good job. That was perfect. Beautiful.
And although it may not look like it, this is actually the finishing touch. This is the layer of concrete that you'll see every time you walk down the Make It Right streets. Big, hard, dense Rice Krispie treat that all the while is sucking up the water and making sure it does not go into the streets. I love it, man.
The concrete will absorb 5 gallons per hour, using Louisiana's natural marshland to keep the neighborhood dry. That same absorbent soil, however, is the biggest problem for engineers building the 2-mile-long surge